Well, this is another Monday, and I hope you guys have had a good Monday. If it's the end of your Monday, or if it's the beginning of your Monday right after midnight, I hope you're going to have a good Monday today. And I was just going to run through a little thing about finding top dead center on any cylinder here. Cylinder number 1 and its companion are always at TDC together, and all the cylinders have companion cylinders unless you're working on a 5-cylinder or a 3-cylinder. And that's giving you a little illustration of how that works right there. Cylinder number 1 and its companion are at TDC together. Any 0 degrees balance or timing mark will line up when both of them are at top dead center. And so basically, if you're lining it up on 0 on your balancer, if you've got that, you're going to have 1 and its companion. It is dicey though if you're trying to find top dead center compression on number 1 and all you're doing is lining up that mark. You may not be on top dead center number 1. I used to be a mechanic at the Ford place that would always just put it on top dead center without finding out if he was on compression stroke or not. And every time he put a distributor back in there, he put it back in there the wrong way. So, and 180 out. One time there was a guy that was working on a van, and it was a 5.8, and 5.8 firing order at 137265548, and a 302 firing order for years with 1542638. And this knothead put the distributor in 180 out on this 5.8 liter van and wired it up with the 302 1542638 firing order. And that thing cranked and ran. It ran crazy. I went back and hooked the scope up to it, and every other spike on the scope was twice as tall. It was weird. After we got it all checked out and got the firing order right, it was just fine. But you find number 1 top dead center by checking a spark plug hole for pressure. Stick your finger in there, your big finger, your thumb, or put a cork or stuff a rag in there, something like that. Bump, 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 bump with a starter. When it pops that out, it's coming up. So then you're going to find your, you're probably going to be back here somewhere with your mark. And keep easing your mark in the forward direction until you stop it on 0. And we're going to talk in a minute about why you don't turn engines backwards. That's really important. So if you have the valve covers off, you can slowly bar the engine over to find the point of valve overlap. And that's going to be the way you'll find, like if you know the companion cylinders, if you know which cylinders are companions, what you can do is you can say, well, I know that 5 is the companion cylinder to 2, and I need to find top dead center on 2. So you bar the engine over until both of the valves are open on 5, and that way you're at top dead center exhaust. Then you go back and you're at top dead center compression on 2. And that's an easy way to find if you've got the valve covers off. You got the valve covers off. When you find that valve overlap, you might notice you got exhaust coming in here. Intake coming in here and exhaust going out at the same time. In this animation, I froze this right here because that's when both the valves are open, very briefly under this valve overlap situation. So and this happens at TDC on the exhaust stroke. So if you know that this companion's on the exhaust stroke, that one's on the intake stroke. Used to have my students I had a 4-cylinder engine out there, 1 and 4 of the companions on a 4-cylinder engine. Had the timing belts on and everything, but the pan was off and the valve cover gasket were off. And I'd say, okay, I want you to put it on top dead center number 4 exhaust stroke. And they'd turn it through, looking at the valves and all that, and say, okay, here it is. And then I say, now put it on top dead center number 1 compression stroke. They'd turn it through a bunch of more times, and then they'd say, oh, okay. I say, well, you found both of them, but you made a C on the exam. What are you talking about? And I say, if you'd allowed the timing marks up, then 1 would have been on compression, 4 would have been on exhaust anyway. And so you worked a lot harder than you need to. You need to learn to work smart, All right, it takes 2 full 360s to complete a cycle. All right, so you calculate your degrees between TDC events using division. 720, use your phone calculator, whatever. Take 720, which is how many degrees a full cycle is, divide that by the number of cylinders, and you're going to find out that, 120 for a 6, 180 for a 4, 90 for a V8, and, it's like 72 degrees for a 10-cylinder. But once you found number 1, you can turn the engine exactly the same, the proper number of degrees forward and find TDC on the next cylinder in a firing order. That's the way it works. But you got to be able to properly and accurately mark the balancer at those degree things. All right, so you calculate your degrees, just like I was talking about earlier. And this is how this would work. See, 1, 4, 2, 5, 3, 6 on this 6-cylinder here. When you turn this thing, then 4 is going to be up here. So you're at top dead center on 4. You turn it again, and by the time you've turned it 270 degrees, you're going to have TDC on number 2. So basically, every time you turn it another 120 degrees, there you are, okay? You're going to be at your next firing order, next firing event. But you got to be on compression to make sure you're on. I mean, if you're not, you don't know if you're on compression or on exhaust, you only got half your information. All right, there's a lot of tools available online for this. On a 4-cylinder with a plug holes directly above the pistons, you can put a 16-inch long heavy plastic wire tie in there. I've seen guys do this, and you can tell where those pistons are in relation to each other. Anytime you want to glance at those tie wraps, you can tell. On a lot of these engines, when you're doing some kind of heavy-duty surgery on them, they basically want you to turn it so the pistons are like halfway down, so you're not going to kiss any pistons with valves. This one student of mine was putting some heads back on a 3.7 Dodge Dakota, like an 04 model, and he still had the cam followers under the camshaft. And I said, you need to take those cam followers out before you put that head back on there. You know, because some of these valves are going to be open depending on where the camshaft is. If you buckle that thing down and torque it, you're going to bend some valves. He did not understand that. He didn't listen to me. He didn't act like he knew what I was talking about, and he bent some valves, and he had to pull the head back off of there. And furthermore, if you've got all the cam followers out, those little roller rockers, you know, you got all those things out, and you got them laid over here to the side. To begin with, you can inspect them and see if their little wheels are, you know, if they need to be replaced. Secondly, it's a whole lot easier to line your timing marks up on your, you know, the color links and all that nonsense if you don't have the camshaft fighting you trying to open valves while you're turning it. So that's just the smartest way to do that, is to take those roller rockers out. But anyway, you can basically get a tool like this. They put this one together backwards. That screw slotted head is supposed to be sticking out the other end, and the end of the screw is supposed to be down inside the cylinder. They just, you know, these people at Amazon, whenever they take something out of the package and put it together, they're going to put it together wrong. It's like putting lug nuts on backwards. It looks good, but it ain't right way. So this one, you can buy one of them. You can build one with a piece of 3/8 all thread, a tap, and a spark plug, and, you know, gutted spark plug shell. I did that just to demonstrate to my students you can do it. So you put the tool in the plug hole. You start with it fully retracted. You gently turn the motor over until the piston makes contact with the screw and stop. If you don't make contact with the screw, move the screw in just a little bit more and turn it through one more time, being really careful to make sure you feel it when it stops. And when it stops, using any reference point you want to. You can make one of your own on the bottom where it's easy to get to, whatever. You mark, make a reference point on a wall pen or whatever, and then you make another reference mark using your whiteout or whatever you choose to use on the balancer, and then you turn it backwards until it touches that thing again. Halfway between those two marks is your top dead center. However, there's a major problem. Overhead cam engines with timing belts and chains tend to jump time when you turn the engine backwards, so don't ever turn an engine backwards if it's an overhead cam engine, because it's just a really bad bet. You know, you might think, well, I've done this a bunch of times and I've never had a problem. The first time you do have a problem, it's going to make a believer out of you. Let me tell you, I had one of my students turn one backwards, you know, because he went past it, and it, you know, and it was bip, 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 and he jumped to some teeth in the gear. We had to put a timing belt on it. Well, don't take a chance going backwards on one. See, I guess if you got one of these old rascals here, you don't typically have a problem with those. You can turn them one way or another all you want to. Occasionally you'll have one that's got a nylon teeth on the timing gear, and that may be wore out. You may have trouble there anyway. But the long and the short of it is, if it's got all these timing chains on it, and these little oil tensioners aren't loaded, you know, some of them have got ratchets, some of them don't. And whenever you turn that thing backwards, you're liable to move that thing, and you're liable to make it go click, click, and then suddenly it's out of time, and you got issues that you're going to have to, you know, if you make a problem like that, you know, you typically have to eat it if you're working on commission, so don't go there, don't turn it backwards. Now, finding top dead center on any cylinder can be done if you know how to do it with this kit right here. I've got one of these kits, Innovative Tool Products of America, whatever the name of the company is. It's a real handy little engine calibration setup kit. Got you a whistle here, you know, with that little cone-shaped thing on the end of it, so you hear it whistle when you're coming up. And you got this spring-loaded plunger. Only use this one on engines that have the piston coming straight up toward the spark plug hole. If that plug hole is in there at an angle and you screw that thing in and you're coming up with a piston, you're going to bend this tool, and you don't want to do that. And that's a little extender right there. Here's this one here has got a similar function from that one, but but now this long within 14 millimeter 1 1/4 thread pitch threads all the way down. Those right there, here's your adapter for your 18 millimeter threads. But anyway, that one there will do the same job as this other tool that I was talking about. Only it doesn't have any moving parts. It's just one long rod that you can screw down through the spark plug hole and make contact with the piston. But anytime you're doing that, barring the engine over, make sure you don't use a starter. Just bar it over real gently and real carefully and all that. This 3-point Sable, 3.0 Sable experience, it had misfire and no compression on cylinder 1. Okay, which I thought that was pretty interesting little thing. So let's just do this. It was one of our trainer vehicles at what it was, and we were just playing around with it to see what we could do. All right, and so what we had here, we decided we were going to start with, we were going to find the number 1. Got a constant misfire. We had no compression on cylinder number 1. Okay, so I said, now we know we've got no compression on cylinder number 1. The next thing we want to know before we tear anything down is, why don't we have compression? Where is it going? And this is just me telling the students, usually if you don't have a compression on cylinder number 1, you put some oil in there and spin it over again. If it comes up, you got a problem with your rings and all that kind of stuff. But I said, let's just see if we can figure out where the compression's going. Now, I've never seen anybody else do this. There may be other shops that do it, but we use this method several times. What we did was removed all the plugs, found TDC compression stroke on number 5. You can do that because 5 had compression. Poof. All right, so we got number 5. All right, so then we rotated the crankshaft 360 degrees to get it to where we knew number 1 was on its compression stroke. Both valves closed, and what we wanted to do is we wanted to see if we could figure out where that compression was going. You can do a cylinder leakage test, but you already know it's got 100% cylinder leakage if it doesn't have any compression. All right, so we used our smoke machine to pump smoke into cylinder number 1 to see where the smoke made its exit, and smoke appeared at the number 3 spark plug hole. None of it came out of the pan, none of it came out of the intake, it came out the number 3 spark plug hole. All right, and so as a sort of an exercise, I told my students, where is cylinder number 3 when cylinder number 1 is on TDC compression? If you start talking to students like that, their eyes glaze over and they're trying to figure it how they can even determine where 3 is when 1's on compression. But it's not that difficult. Cylinder 3 had just fired 2 combustion events prior to number 1 reaching TDC compression. That means number 3 is on its way up on the exhaust stroke. The exhaust valve in number 3 is open, and so whenever we pumped smoke into number 1, it went past the burn valve through the exhaust, and enough of it made its way up into the back up into the engine through there that it wound up coming back out number 3. And so that told us right there we had exhaust issues. Knowing where the number 3 cylinder was key to that thing, though. But we didn't get any smoke out of any other cylinders, interestingly. I figured we'd have seen some out of some other ones, but we didn't. And it turned out that that engine had a burn valve on cylinder number 1. All right. Now, these old flathead engines were always interesting. Back in the day, whenever Ford first started making V8s, they were flatheads. And that's kind of the way these work. This reminds you of a Briggs & Stratton lawnmower engine. Except this one here, you might notice, has got coolant in it. It's got a water jacket and all. Got a big quench area there on the piston. We'll do a little more studies on engines. I got some material on that we can look at, which is where I got this illustration from. Pretty interesting little thing. So you got your camshaft down on the bottom, and it's opening the valves, and basically your piston is getting its charge in here, and when the spark plug lights off, it heats that nitrogen up and drives the piston down, so on and so forth. The reason headers are better, by the way, I don't know, a lot of you guys, gearheads usually know this, but the exhaust flow interference from a manifold. You got This one here, when the exhaust is coming out of this one, it's going to interfere with the exhaust that's trying to come out of this one, and basically it's got these puffs of exhaust coming out of that thing, and so it doesn't really breathe as well with a manifold like this as it does with headers on it, because on the headers down here in this area you usually have a collector that whenever this exhaust is coming out of here, it's basically pulling the exhaust. It's creating low pressure. They call it extractor exhaust, sometimes they do, and it's pulling the exhaust out of the cylinders instead of letting them get hung up coming out of these cylinders right here. And so I thought you guys might enjoy thinking about that for a minute. One time I had a pickup truck I was trying to get better fuel economy on, and I put headers on it. You know, it gave me more power, but it didn't help my fuel economy. But a lot of vehicles started having headers on them right out of the factories. Your Mustangs, a lot of your Jeep Cherokees years ago started having headers for exhaust on them, because it's just a, you know, it makes the engine not have to work so hard to push the exhaust out, because the exhaust system is designed in such a way where it draws it out. Furthermore, they go out of their way to try to make sure all of the pipes are the same length, if there's any way they can. See, and that's kind of like when your intake, they want all of the intake runners to be the same length too, so that everybody gets the same amount of everything. Well, that's going to finish me off this time. I really appreciate you guys coming around and listening. This is a short video, but I really had a good time with it, and we'll see you guys.